Good morning. Oh, I'm mute. Good morning.
Good morning.
This guy.
Good morning, Sir.
This guy.
A couple people signing in, so let's make sure to check them off here real quick. Any questions for me before we get started today? Alrighty. Just a reminder while I'm thinking about it, debate club today at lunch. Still looking for people to sign up for the sides on Slack, so do that, please. All right. Okay, we're going to get started here. Today we're doing 4.2, which is adding and subtracting rational functions. Okay. So there's a couple questions in here that kind of take a step back, looking at Unit 3 of, how do we simplify... A couple people in chat. Yes, please. How do we simplify rational functions, or how do we simplify fractions? So... For instance, there's a couple on here. Let's say I had x squared minus 25. There's something like x minus 5 over x squared minus 25. Okay. If I asked you to simplify this expression, what might indicate that you're able to do so?
If you factor the bottom, the denominator.
Good. So if you can factor the denominator, then the fraction or the expression is able to be simplified. This is a difference of squares. So x squared minus 25 is equal to x plus 5 times x minus 5. And then what can you do?
And now you can just get rid of the top and the bottom, because they both have the same.
Perfect. Which would leave me with 1 over x plus 5. And it doesn't have to be a difference of squares. X plus 2 over x squared plus 6x plus 8. Like the denominator is able to be factored, therefore we can simplify it. So in the denominator, what am I going to do? Or what is it factored? What numbers multiply to get 8 but add up to 6?
4 and 2.
Thank you. Which means those cancel out, leaving me with 1 over x plus 4. And then number 3, do one more. Could be x plus 7 over x squared plus 14x plus 49. Denominator here is an example of a perfect square trinomial. So to factor that, I'm looking for what numbers multiply to get 49, but add up to 14. That would give me x plus 7 squared. So I can cancel out an x plus 7 on top and bottom, leaving me with 1 over x plus 7. So that's just a little bit of a review. We did that when we were looking at the dividing polynomial section. Messing with my settings here. A couple people signing in here. Alright. So that's just a little bit of review of like how we want to simplify. I'm going out of order here a little bit, but if we are looking at problems where we have to add and subtract expressions, just like if we add or subtract fractions, if we can, we're going to simplify once we're done with our operation. So there's a couple questions on the assignment they're going to ask you to do that. Let's go here. So the easier examples, you're just going to have situations where you have the same denominator. So let's say 1 over x plus 3 over x. If I have two fractions that have the same denominator, what do I do?
Add up the numerators.
Good. All right, so you keep the denominator, you add the numerators. That process is going to be the same when we're adding or subtracting rational functions. So as long as the denominators are the same, all you have to do is add the numerators. Is the video lagging or is my voice lagging? The video? Okay. Bear with me. I'm playing with my settings here. Like I said, I'm trying to do the stream and Zoom at the same time, and I'm just trying to troubleshoot. It's not if the internet connection's fine, so, you know, I think it's Zoom, unfortunately, but I'm trying to adjust as I'm going through, see if I can find a good balance. Let's see. So same thing in the rational functions. If the denominators are the same, more people logging in, then you're going to keep the same denominator. You're going to add the numerator. Same thing here, x plus 3 over 2 plus x over 2. Okay. Same denominator, so we're going to add the numerators, keep the denominator. X plus 3 plus x.
2x plus 3.
2x plus 3. And it doesn't have to be just a monomial in the denominator. You know, so you could have something like x squared plus 3x plus 6. 2 over that plus 4 over x squared plus 3x plus 6. So as long as the denominators are the same, you're going to add the numerators. So what will we get here? Yeah, go ahead. So as long as the denominators are the same, then you're just adding the numerators. So both of these have a denominator of x squared plus 3x plus 6. So then we're going to add the numerators. 2 plus 4. Which is 6. So those should be pretty straightforward. Again, if the denominators are the same, you just have to add the numerators. That's all you're doing there. Okay. Now, let's say I have different Let's say I have different denominators. So just like with fractions, what's one way I can add or subtract fractions with a different denominator?
Make the denominator the same.
Okay, good. So one way is to make the denominators the same. So on the left-hand side, you're looking for, remember, least common multiple. So you're looking at the multiples of 5, 5, 10, 15, etc. You're looking at the multiples of 2, 2, 4, 6, 8, etc. And you're looking for the first number that they have in common, which would be 10. So on the left fraction, I multiply that by 2. On the right fraction, I multiply it by 5. That becomes 6 over 10. A couple people signing in. Remember, if you're signing in late, to just let me know in chat why. And then minus 5 over 10, which would give me 1 over 10. So that process is going to be the same with rational functions. If the denominators aren't the same, we're going to make them the same. What's another way that I can add or subtract fractions? Okay, thank you in chat. What's another way I can add or subtract two fractions? In chat, yeah, so like butterfly or TP method, so you do 4 times 5. And then 3 times 2. Over 3 times 5. So add the numerators. You get 26 over 15. If you can, you'll have to simplify, but here that's not able to be simplified. So that would be our answer. So using either of those techniques, we're going to apply that to rational functions. It relates to rational functions in that it's the same process, right? You have to either make the denominators the same, or you can use butterfly method. So, 4 over, let's say, 2x. Let's see, let's say 4 over 3x plus 7 over 5x. So what would be the least common multiple of the denominators?
15.
Good, 15x. So multiply the left expression by 5, multiply the right expression by 3. That gives me 20 over 15x. plus 21 over 15x, which would be 41 over 15x. This also applies if, again, we have something other than a monomial in the denominator. So let's say 4x times x plus 1 minus 3 over x plus 2. So these are a little bit more difficult to, we'll say, determine what the denominator is supposed to be. Basically, when you have something other than a monomial in the denominator, what you want to do is you want, just like we did here, right? At the very least, I can multiply the fractions by each other, right? So I multiplied 5 to 3, I multiplied 3 to 5, and that got me the same denominator. So if you have expressions as your denominators, you multiply the fraction by each other. So the left term, I would multiply by x plus 2 on the bottom. And of course, if I multiply x plus 2 on the denominator, I have to multiply x plus 2 on the numerator to keep it balanced. And then on the right-hand side, I'm going to multiply that by x plus 1, top and bottom. And if I multiply by x plus 2 in the denominator, I have to multiply x plus 2 in the numerator. Sorry, x plus 1, rather. Okay. So now I have the same denominator, x plus 2 times x plus 1. In the top, what I'm going to do is I'm going to distribute the 4x into x plus 2. Now I'm going to distribute the 3 into x plus 1. So that gives me 4x squared plus 8x on the left. And then on the right, that gives me negative 3x minus 3. If I can, I'm going to combine like terms. So I have 4x squared plus 5x minus 3. And that's over x plus 2 times x plus 1. Okay, hang on. And then depending on the instructions on the assignment, it might want you to leave it like that, or to multiply out the denominator, in which case you would do x plus 2 times x plus 1, which would give you x squared plus 3x plus 2. Give me 1 second. Okay, sorry about that. Okay, so let's say going to the next one. Now, remember, if you can simplify, you need to. You won't always be able to, but if you can, you need to. So, as an example, let's do say x over x plus 4 plus 5 over x plus 5. So here, the left fraction I'm going to multiply by x plus 5, top and bottom. On the right, I'm going to multiply by x plus 4, top and bottom. Okay. So I have x plus 5 times x plus 5 times x plus 4 and that's over x plus 5 times x plus 4. Distribute your x. Distribute the 5. Five x plus 5x gives me 10x. And then in the denominator, either keep it factored or you can multiply it out, which would be x squared plus 9x plus 20. Questions so far? All right. What? No. Stop asking me about chips. All right, number 10. Mr. Berger, did anyone else log in the last few minutes?
One Avalos.
Thank you. Remember, if you guys are logging in, just message me in chat while you're late. Okay, and number 10, let's do... x squared over 3x minus 4 over x. Now, an example like this, there's a couple things you could do. One, you could multiply first and combine like terms, or I see here that this fraction on the left is able to be simplified. So if you do that first, divide an x on top and bottom, then you have two denominators that are the same, in which case you just subtract the numerators. So 3 minus 4 gives you negative 1 over x. All right, we still got quite a bit of time. What I'm going to do I'm going to start you on your assignment. Of course, make sure your notes are completed. Okay, hang on. But do that for me first real quick. Make sure your notes are completed, and then we'll go from there. So let's look at a couple of these examples here. These are examples from the assignment. Your order is randomized, but do some more difficult ones here. So let's say 1 over 2 plus x minus 2 minus x over x. So to make it so that I have the same denominator, what do I need to do on the left-hand side? So again, the goal here, we're trying to make it so that the denominators are the same. So on the left, I need to multiply it by x. So multiply by x on top and bottom. On the right, I'm going to multiply by 2 plus x. Okay, and so on the left you end up with x over x squared plus 2x by multiplying that x into 2 and x. On the right, end up with 4 minus x squared over x squared plus 2x. Now we have the same denominator. Be careful that this is subtraction. So this is x minus a negative x squared. And that's minus 4 over x squared plus 2x. Okay, do another example here. 3 over x squared minus 4, and this is from the assignment, minus x plus 5 over x plus 2.